Hello again. Here we are to talk about data visualization with JavaScript. And today's lesson is lesson number 6, right? Real-time data. And where I'd like to start today is with assignment 3. And the goal for the assignment is to make an audio visualizer with JavaScript. So I'm going to click on assignment 3 here. And the learning objectives for today are to use Canvas to display data, right? So we're going to translate numbers into drawings on Canvas. The second learning objective is to display data in real time. So instead of just showing like a graph and then stopping there, what we're going to do is we're going to update our graph or update our drawing all the time so that it moves and we see the data change over the course of time, right? And then last, we're going to use normalization. So normalization is the idea of taking a value and turning it into another range of values, right? So, and we'll do that because the audio data comes in a certain range of values, and we'll need to translate that into a range of, colors or a range of pixels on the screen or width and height of the canvas. Let's see here. So let's go review the starter code for this project to make sure nobody runs into any problems with that, because there's a couple pitfalls with this, right? So what I'm going to do is I'm going to go get the starter code, which is in this folder here. So I'll click here and choose download as zip. And I'll open up the starter code here on my desktop. And I think I'm going to open it in VS Code. Let me close that down and open this thing up. Here we go. So here is the starter code in VS Code. Let me zoom in a little bit. And the index HTML is the entry point, right? And it's a pretty standard web page here. It's got the head, the title, the style tag. You could move this to its own document if you wanted, but it's got some basic styles there. And then at the bottom here in the body, it has a canvas, which is width and height 300. And then it has two buttons, right? So it's got a play and a stop button. And then last of all, there's a script tag here, okay? And the script tag is set to type module. So note that, and we're pointing to main.js. So let's open this up in the browser. And what's going to happen is it's not going to work, right? So let me find reveal in Finder, and I'll drag this on top of my browser here, and nothing happens, right? And if I go to the console, and I'll notice that there's an error, and when I read the error here, it says, null is not allowed, cross origin or access control only, right? And it's giving me a CORS error. So it says cross origin resource sharing policy, right? So that's the error that we're getting. And the problem here is that this project is using a script with type module, okay? And so a module allows us to use the import from syntax to import other files into our JavaScript files. And that's super convenient and really great, but it's also a security risk, right? So if anybody could modify your JavaScript and add an import statement, they could import their JavaScript, and who knows what would happen at that point, right? So how do you get the code to run? Well, what I'm going to do is I'm going to close the page there, and instead I'm going to run this code from a local server. So I'm going to use live server with VS Code, and it's a plugin, so you can add that. You can go to code. Let me go. Where's my where's the plugins there? Oh, here they are, right? Sorry. For some reason, I know they're on the menu here, but anyway, so here's my plugins, right? And if you type live server in here, right, you can, live server, right? So I opened up live server. You can see I have it installed already, So you can install it, and when you install it, what it will do is it'll add a live server button, and there's also an option on the menu up here too, so you can use it from there too. But it usually puts this little menu at the bottom here that says Go Live. It's on the blue bar. Go Live right there. And if you have an HTML project and you click on the index HTML or the whatever HTML file you have and you click Go Live, what it'll do is it'll launch a server and then open that file in the local server. Okay, so this is totally different than what we saw earlier. If I click the button, now my audio visualizer is working, right? And so the visualizer here, let's talk about this for a moment. So it's playing the sound of some birds chirping, and what it's doing is it's analyzing the data from the audio and drawing lines out from the central circle to the like uh, the height of the loudness of the audio at any frequency range, right? Let me explain that again, right? So essentially, like, the audio player is grabbing an array of numbers, and all those numbers are in the range of 0 to 255, and there's 1,024 numbers. So when I look at the audio here, you can imagine that I've divided the circle into 1,024 slices, okay? And then I'm drawing a vertical line out from the center, right? And this canvas that we saw was 300 by 300, so I'm not drawing them out from the center from 0 to 255 pixels, right? I need to scale that value. So what I've done is I've normalized the values to a range of 0 to 1, and then I multiplied by the height that I want the lines to move outward from, okay? So I have an array of data, 1,024 values, and each value represents the loudness of the audio at a particular frequency, okay? And it's been divided into 1,024 frequency bands, okay? And then for each of those frequencies, the value is in the range of 0 to 255. And what we did is we divided each of those numbers by 255 to get a value from 0 to 1, right? So that's the normalization, and then we can multiply by a range to get the length of the line. And I think my lines are like 80 pixels or something, right? And that sets the height. We can check out the source code here. Let's take a look. So again, everything starts in main. So I'm going to go to main.js here and take a look at our source code, right? Let me rearrange these windows a little bit. Okay. And at the top here, I kind of started with some code from another story on the internet, and I have some other links here to some more information. So you can follow that if you want and take a look at the source code there. My source code is down below, and at the top here, what I've done is I've divided the renderer, the process that draws all the lines. Okay, I've divided that up into separate files called renderers, right? So I've got a circle renderer, I've got a circle grid renderer, I have a circle center renderer. I just had to think of names for each one. I've got the vertical bars renderer, the vertical bars mono renderer, the radial ray renderer. Okay, sounds interesting, right? We're not using these right now, so we're only using one renderer at a time, okay? The renderers are basically just a function that you're going to pass in the values to, and then it's going to just draw on the canvas one time. And our system down below is going to call the renderer over and over again, right? And then that's what's going to create the animation. Okay, so here's our renderers we've imported, and your goal is to write your own renderer, okay? And you can examine the ones that I have here as samples, okay? Next, we need to get a reference to the canvas. So here we've got a reference to the canvas by its ID name, and then we get the canvas context here, okay? So we'll need that to be able to draw on the canvas. Next, there's a couple play buttons. So I have the play and the stop button. I guess I called this pause button here, but it's really a stop button, right? So I've got a reference to these two elements by their ID name, and then I gave them an event listener. So if you click, if you click start, it's going to call start audio, and if you click the pause button, it's going to call pause audio. Okay, so now we get into the audio. Okay. At the bottom here, I have a couple variables. So I have the analyzer, the frequency array, and audio. Okay, so we're going to use these to store information about the audio. And then we have the start audio function. So how does start audio work? So the first thing it does is it makes a new instance of the audio object. Okay, so this allows us to do things with audio in JavaScript. Okay. And then what we're going to do is we're going to get the audio context. So this is a lot like Canvas, but unlike Canvas, where Canvas draws pixels on the screen, the audio context allows us to manipulate audio data. Okay. There's a little block here where it says new window.audio context or new window.web audio context. It depends on what system you're on. So, on most systems it should be this. But if some systems or older browsers may not support that, you'll have to use the WebKit extension, right? Next, right? So we've got our audio context. Now what we're going to do is we're going to set the source on the audio object up here to the name of the audio file that we want to play. So right now we're listening to the birds whistling wave. And maybe I'll change that to this sine wave, right? And I was using the sine wave for testing because it kind of sweeps through all of the frequencies. So you can see it's doing the low frequencies here, and then you can kind of hear it working its way up through the frequencies there. And this was kind of good just for testing, right? And it also lets you see like how long the lines go and kind of make sure that my audio is covering the entire circle there. It didn't quite get over to here, but I think I've got those covered. Anyway, so you can put your own audio in here if you want. Throw an audio file in the folder and link it as the source. Okay, so now let's talk about how we're going to analyze the audio. So the first thing we need to do is we need to make an audio analyzer, right? So we'll go to the audio context and we'll call create analyzer. Okay, so the analyzer is what is going to do the job of looking at the audio and returning to us the array of 1024 frequency values, right? Okay, and then we're going to create a source audio element and then connect it to the source analyzer, right? Or connect the source to the analyzer. This is like, we could just do a whole nother class on audio. So I'm not going to dig into like why and how all this works, but essentially like the audio object in JavaScript has a bunch of like, imagine it as a bunch of little modules and you can connect them together. So you can do a lot of pretty amazing things here. You can create an audio generator. So you can create a frequency generator and then you can chain that or connect it to another, like a gain module. And the gain module changes the volume, right? So you could create like a tremolo effect or some other effects, right? And there's a whole bunch of these and you can kind of connect them all together. And essentially the audio just gets piped through each module as you connect them together, right? In our case, we're just going to connect to the analyzer, right? Because that's all we're using. Next, we're going to set the analyzer and give it some source audio so it knows what to look at. So this stage, we're going to get the audio context, destination, and somehow that connects us. Again, I'm a little confused by this too. This is going to connect us to the audio source up here and give us the data coming in, right? Okay, so this we can look at that as kind of boilerplate code. And here's where we get into the stuff that we need to know about, okay? At the bottom here, you can see there's a frequency array. And this frequency array, I'm going to initialize it as a uint8 array. So what this does is it creates an array, just like you're used to, but instead of an array that holds any kind of thing that's the normal JavaScript array, this creates an array that holds only um, unsigned integers that are 8 bits. So this array is more efficient than the regular one, but it can only store numbers between 0 and 255. Okay, so an unsigned integer doesn't have a negative, positive sign, and it's 8 bits, so it only holds a value from 0 to 255. Okay. And we need this because our audio data, there's a lot of it, and we want to make it as efficient as possible because we're going to display it in real time, right? So, so here we're making a uint8 array, and then we're going to call analyzer.frequency bin count, and this returns a uint8 array. Okay, so we're going to initialize this with the starting array of frequencies from our audio source. Okay. You can uncomment this and you'll see that it gives us 1024 values, okay? So after we've got our audio connected and we've created the analyzer, we're gonna get an array of audio data. And then what we're gonna do is we're going to call audio.play, and that'll start playing our audio. And what we're gonna do is we're gonna call request animation frame render. And what this will do is it'll call the render method down below, and it'll, like, request animation frame is used for animation, and the idea is that when the browser is ready to redraw the screen in the browser window, it will call request animation frame with this function, right? So request animation frame is going to take in a callback essentially, and then call that callback when it's ready to redraw the screen, right? So here we've set up the render method, and when we call render, it's going to generate some numbers that figure out the width and height of the canvas, and then it's going to get the analyzer frequency array again, or the frequency array from the analyzer, and then it's going to call the circle renderer with the frequency array, the context, the canvas context, the center of the canvas on the X and the Y, and the radius, right? And then at the last step, we're going to call request animation frame with render again. So we started here, we got into this function here, and when the browser was ready to draw, it called this function for us because we passed the function in here, right? We did all the code here, and then at the bottom, we're going to set up another request animation frame. So the next time the browser's ready to draw again, it's going to call render again. And so this will create kind of a loop, and that's why when we play the audio here, it's updating in real time. So every time the browser's drawing, it's calling this request animation frame again, and then it's doing all the code here. So every time the browser's ready to draw, we get the frequency array from our frequency analyzer, and then we call the circle renderer and we pass in the information. So what's important here is that the renderer takes in the information it needs to draw one frame. So it just needs to draw the drawing here one time, and then we're going to pass new data to it each time we want it to draw. Okay, so that like the way I set this up is, and you can do your frequency renderers like any way you want. The way that mine are working right now is they takes in the frequency array, so that's the array of frequency data, the reference to the canvas context, and then any other information, any other numbers that it needs to draw. And some of these take different values here, but for this one, I needed to know the center of the canvas and the radius that I want the circle to draw to, okay? So that should get you started. What I want you to, actually, before we cut this video off, because this is going on a little bit long, Let's test out the other renderers. So to test out the other renderers, I'll just uncomment them here, right? And then when I play, you can see that this one generates the circle grid renderer, generates the audio data as little colored circles, and it puts them in a grid. So our lowest frequency is in the upper left corner, and our highest frequency is in the lower right corner. Actually, it doesn't work out to be an even number, so the lowest frequency, or the highest one, is like about here, but you can't see it, so it doesn't matter. Right, so there's our circle grid renderer. I should have come up with some better names, right? Let's try the circle center renderer, right? So I'm going to save, and then I'll run my code here, and this one just creates a bunch of circles, and the color of the circle is the frequency, and the diameter of the circle is the volume. Okay, so how loud the audio is at that frequency. Okay, so why don't you try out these other renderers and test them out, and then come back and we'll continue in the next video.